Hello dear students, welcome to Physics Online CET classes for class 12 students. Today I am going to start first year topic chapter number 5 Laws of Motion. As we have completed first year part 1 up to gravitation chapter, already we have completed. The last chapter remained is Laws of Motion. I will start in today's session. So first we go for the important terms whatever we have studied in laws of motion and which are very important for your competitive examination. Only those points I am going to discuss in today's synopsis class. With that we can solve multiple choice questions. So let us start laws of motion online CET class part 1. So in this chapter, we studied what is a force, what is a friction, what is circular motion. These are the three important terms we have studied in this chapter. So in force, we studied Newton's first, second and third law of motion. With that, we studied what is inertia, what is linear momentum, what is impulsive force, and also we derived law of conservation of linear momentum and the applications of law of conservation of linear momentum. This is first part. The second part is about friction. In friction, we studied there are three types: static, kinetic and rolling, their examples and their equations. And also we studied advantages, disadvantages and how to reduce friction. This is second part. The third part is circular motion. In that we have studied what is centripetal force and centrifugal force, their differences. And also we derived motion of the car on a level circular road as well as banked circular road. So this is what a brief introduction to laws of motion. So we can go for only the important terms we have studied in this chapter and which are very important for your competitive examination. Only that part I am going to discuss because we studied all these basic terms in your regular theory classes. So we can go for other than that which are related to multiple choice questions. Yes, I am going to explain free body diagram. So this is very important concept and you can get multiple choice questions based on this topic and you have not studied much in your theory classes. So I want to explain free body diagram. So you can observe free body diagram, what it means. When number of forces act on a body, the resultant force on it produces acceleration in its direction. So in which direction you are going to apply number of forces, in that direction the body starts to accelerate, means a change in velocity takes place. An object of mass m, they had given an object having mass m. This object is suspended vertically by a string of negligible mass. Here you can observe this diagram. They had given a rigid body having mass m. And this mass of the object is suspended vertically with the help of a string and that string is having very negligible mass. Then how to write a tension in the stretched string? In this stretched string, remember when it is hanging vertically downward, when it is suspended vertically downward, always tension is opposite to that and that tension is given by the formula T equal to m into g, where m is mass and g is acceleration due to gravity. So this is also a type of force because you can observe the equation for force is F equal to m into A. So there we are going to consider acceleration of a body. When it is connected to the string, we should consider acceleration due to gravity. This equation you have to remember. The tension in the stretched string is T equal to m into g. Right? Then you can observe the second case. If the system is pulled outward with an acceleration A, then tension in the string is, if I am going to pull that rigid body upward, So when we are pushing or when we are pulling that object, rigid body in upward direction, then how to write a tension equation? When you are pulling the system in upward direction, we know the general formula is T equal to M into G. But when you are moving in upward direction, there certain acceleration occurs, because we know that when a number of forces are acting in a direction, so that the system starts to move in the same direction with certain acceleration. So when it is moving in upward direction, so we have to write this equation T equal to M into G plus A. G is acceleration due to gravity and A is acceleration of the body because the object is moving in upward direction. This is second case. Remember, when system is pulled upward, you should write M into G plus A. Then third equation. If the system is moving downward with an acceleration A, then tension in the string is given by the formula exactly opposite to that, T equal to M into G minus A. So here we are moving that system in a downward direction. So we can write the net acceleration, that is G minus A. G is acceleration due to gravity. These equations you should remember. The first case is when it is connected to string, T equal to mg. When it is pulled upward, T equal to M into G plus A. When it is moving downward, T equal to M into G minus A. These three equations you have to remember. Go for the fourth condition. If the string has mass M, then tension in the string at the upper end is. So if the string, so till now we considered negligible mass to the string. Suppose the string is having certain mass M, then how to write a tension? Remember, T equal to capital M is mass of a rigid body. Small m is mass of the string because string is connected to this rigid body. So the equation becomes T equal to M plus M into G. When you have to write this equation, when the string has a certain mass, we can write M plus M into G. And here we can consider this equation when the system is at rest. It is not moving upward or downward. So in this condition, just you can write M plus M into G. Suppose the system is moving in upward direction, moving up with acceleration A. How to write the equation? So you can remember the condition B. The same equation, M plus M into G plus A. It is moving up. When it is moving down, you can write M plus M, keep as it is G minus A. So these three equations you can write when the string has a certain mass. Next point. Masses connected by a string, they had given two rigid bodies M1 and M2. Masses, these two masses are connected by the string and suspended from the rigid support. This is the rigid support. With the help of this rigid support, two bodies or more than two masses connected by the string. Then tension in the string when force F is applied down as shown in the figure. So if I am going to pull that object in a downward direction, if the applied force is downward, you can observe the arrow mark. M1, M2 are connected by the string so that tension is created upward. T1, T2, because there are two objects here. When force is applied downward, then how to write tension in the string? Remember, I am going to write the equation tension in the string T1 between M1 and M2. What is the equation? Generally, we know that T equal to M into G. But here, I am going to write this T1 is created, but the applied force is downward, right? So, we have to write F plus M2 into G. So, why we have to write M2? Because M2 is downward. This is second object. Is it clear? So that because of this M2, tension is created upward, not because of M1. So we have to write F plus M2G. This is tension in T1, means between M1 and M2. Then total value tension along the string T2 value. How to write? The total force is F plus how many objects are connected? Two objects having masses m1 plus m2 into g. This is general equation. If there are three bodies, you should write the equation m1 plus m2 plus m3. If there are four bodies, m1 plus m2 plus m3 plus m4 and so on. This is a standard equation. T1 is F plus m2 into g. T2 means this is the total tension. So F plus m1 plus m2 into g. Is it clear? So this equation you can remember when masses are connected by the string, and remember this is the force applied in a downward direction. Now we go for simple multiple choice questions based on this concept. Three blocks of equal masses. You can observe they had given three blocks of equal masses, means each block is having mass 3 kg. It is given each 3 kg. They are suspended by the weightless string as shown in the figure. So here they had given the string has negligible mass. If applied force is 100 Newton, the applied force is downward 100 Newton, then T1 is equal to, what is the value of T1? So remember which equation you can use to calculate the value of T1. Just now we studied T1 equal to F plus, let us consider this is M1, M2, M3. We have to find the value of T1. You can observe this is M1, M2, M3. T1, T2, T3. This is having mass M1. Is it clear? So, or each mass is same, there is no problem. So, what is the formula? T1 equal to F plus M1 into G. This equation you have to use here. Everything is given, calculate, and the right option is option A. You will get the answer 130 Newton. So, how we got this answer? You can observe what are the givens. Mass of three objects are given, M1, M2, M3 is equal to 3 kg. Applied force downward, that is 100 Newton. Acceleration due to they had given g equal to 10 meter per second square. We have to find the value of T1, right? Now, you can observe the formula. T1 equal to F plus M1G. If you want to calculate T2, then how to write the formula? T2 equal to F plus M1 plus M2 into G. For T3, M1 plus M2 plus M3 into G. Remember that equation? According to that equation, substitute T1 equal to. So, force is given, mass of first object or mass of each object is same M1 and G. So, first they had wrote M1 into G. M1 is 3 into G value is 10 plus force is 100. So, 3 into 10 is 30 plus 100 is 130 Newton. So, option A is the right answer. Is it clear? Or you can observe these equations. When masses are connected by the string and suspended from the support, then tension in the string when F is or the force is applied down as shown in the figure. So we have the formula T1 equal to F plus M2G or T2 equal to F plus M1 plus M2 into G and so on. Right? So these formula you have to remember to solve these type of questions. Now we go for motion of the connected bodies. So contact force, the force acting between two bodies in contact with each other. So you can observe M1 and M2, they had given two bodies of masses M1, M2, both are in contact with each other. So between them here you are having contact force, right? The first point, masses in contact on a smooth horizontal surface. This is a smooth horizontal surface, on that they had kept two bodies, both are in contact with each other, having masses M1 and M2. Is it clear? Now, we are applying a force in forward direction. This is the applied force. And what is F12? F12 is contact force. This is contact force between two bodies. So, how they are contacted? F12. This is the contact force direction. That means Contact force is force due to M2 on M1. Is it clear? Force that is due to M2 on M1. It means M2 is applying force on M1. They are in contact with each other. So in these cases, how to write the equation for acceleration of the system? Remember, you are applying force in forward direction. Contact force is exactly opposite to that. So you go for this equation. A equal to F divided by M. You can remember F equal to Ma or A equal to F by M. In place of M, you are having two bodies, M1 plus M2. So this equation you can directly write. It is very easy. A equal to F by M. But there is no only one body here. There are two bodies, M1 plus M2. If there are three bodies, M1 plus M2 plus M3. Is it clear? This is acceleration. Then what about F1 to contact force equation? Contact force is the force due to M2 on M1. So M2 is applying force. So we can write force, contact force F12 is equal to M2 into acceleration A. This is also like F equal to Ma form. But who is applying force? M2 is applying force. So you can write M2 into A. What is F12? Contact force is the force due to M2 on M1. Now, second point. Contact forces as shown in the figure. Now they had given three bodies. All the three bodies are in contact with each other. M1, M2, M3. Is it clear? We are applying a force F in forward direction. How to write acceleration? A equal to F by M. In place of M, you can write M1 plus M2 plus M3. This is acceleration. Now tell me how to write contact force between M1 and M2. How to write the equation M1 and M2? So we can write F12 is equal to, so M2 is applying force on M1. Is it clear? Right. So on M2, already M3 is applying force. Always they are in opposite direction. M3 is already applied on M2. So we can consider M2 plus M3 together they are applying force on M1. Contact force due to M1 and M2. But on M2 already M3 is applied force. So we can write M2 plus M3 into A. This is contact force between M1 and M2. Then third point, contact force between M2 and M3. M2 and M3 means M3 is singly applying force on M2. So you can write F23 is equal to M3A. Is it clear? This is very tricky. You can remember these equations. They can give any number of objects. Easily you can solve the multiple choice questions. Right? Yes. Now we go for multiple choice question on this concept. Try to solve yourself. Three masses 16 kg, 8 kg and 4 kg all are placed in contact as shown in the figure. If a force of 140 Newton is applied on 4 kg, then the force on 16 kg will be. Yes, here you should observe the applied force. Where they have applied force? On 4 kg they have applied force in this direction. All these three bodies are in contact with each other. So when you applied force here, we have to find the force on 16 kg. Then try to solve yourself. What will be the answer? Yes, the answer is 80 Newton. How we got this answer? Go for the givens. Mass is given M1, M2, M3, 16 kg, 8 kg and 4 kg. Applied force is 140 Newton. So we have to find force on 16 kg. So let us take it as F dash. We have to find F dash here. We know that acceleration of the system A equal to F divided by M1 plus M2 plus M3. But I want force. So force equal to what? F equal to Ma. So F1 equal to M1A. Right? Or you can take it as F dash. F dash equal to M dash into A or M1 into A. Then you can multiply here. A value we already know that. Multiply M1 into F. Remaining keep as it is. So F1 is equal to, let us multiply M1 means last object, that is 16 into 140 Newton divided by 16 plus 8 plus 4. We got 80 Newton. Remember, we know acceleration formula. Just I want 4, so F equal to ma. Let us multiply m here. You will get the answer 80 Newton. Or you can observe this hint here. Acceleration of the system formula, we already know it. Contact force between m1 and m2. Contact force between m1 and m2 means what? m2 plus m3 into A. Contact force between m2 and m3 is what? m3 into A. These equations you have to remember. So answer is 80 Newton. Now we go for motion of bodies connected by the string. We go for motion of bodies connected by string. The first point, when two bodies of masses m1 and m2 are tied to the ends of a string, you can observe the diagram m1, m2. These two bodies are tied to the ends of the string and are kept on a smooth horizontal surface. They are pulled by the force F. They had given two bodies m1 and m2. These two bodies are connected by the string. They kept on smooth horizontal surface and we are applying force in this direction. Right? We know that the forces acting on the body, vertically downward force is weight of the block is vertically downward, W equal to mg. Here it is m1g. For second object it is m2g. R1, R2 are normal contact force. So this is always perpendicular to the given surface. This is normal force or contact force, or you can take it as normal reaction. This is weight of the block. These are vertical forces. These two bodies are connected by the string. Horizontal forces are applied force F and tension in the string. Tension along the string. So in these cases, how to write the equation for acceleration as well as tension? We know general formula A equal to F by M. It is very easy. F divided by M. In place of M, directly you go for M1 plus M2. How to write tension? Tension along the string T equal to M1 into A. Is it clear? T equal to M1 into A, because this string is connected between two bodies. Always tension is exerted in opposite direction. So T equal to M1 into A. So in place of A, write this equation F by M1 plus M2. You will get the final equation M1 F divided by M1 plus M2. So T equal to M1A. In place of A, we wrote this equation. This equation you have to remember when two bodies are connected or tied by the string. Now, second case, if in the above example, three bodies are pulled with the force F. Instead of two bodies, I considered three bodies, M1, M2, M3. All these three bodies are connected with the help of a string and we applied force in this direction. How to write the equation? Acceleration produced in the system is A equal to F divided by M1 plus M2 plus M3. This is acceleration. Tension produced in the first string. Here, for the first string, tension is produced because of M1. So we can write T1 equal to M1A. What is the value of A? We have this equation. Substitute here M1 F divided by M1 plus M2 plus M3. So you will get a tension produced in the first string. Similarly, how to write a tension produced in the second string? In the second string, we consider two objects M1 plus M2. Is it clear? Into F divided by M1 plus M2 plus M3. Because we know that tension and the force, since F minus T2 equal to M3 into A. That is force. This is what? Net force acting on the second body. F is applied force and T2 is created tension. Difference between them, that gives the net force between them, F minus T2 equal to. This is what? MA equation, F equal to MA form. So A keep as it is. We should write M3. Then similarly, tension produced in the third string. Tension produced in the third string T3 equal to, directly we can write force F, because at last part the force is applied. So we can directly write how much force is applied, that much tension is created. T1, T2, T3. These three equations you should remember. We go for multiple choice question based on that concept. Three blocks of masses M1, M2 and M3. Three blocks they had given, they are connected by a massless string. Means the string has negligible mass. As shown in the figure on a frictionless table. They had kept this block on the frictionless table. They are pulled with a force. They are pulled with a force and they had given T3 equal to 40 Newton because T3 is equal to F, right? M1 value 10 kg, M2 is 6 kg, M3 is 4 kg. Then tension T2 will be, what is the value of T2 that we have to calculate? First, you can observe the answer is 32 Newton. We go for the diagram T1, T2, T3. This is a created tension in the string. Three objects are connected by the string they kept on the frictionless table. So what are the givens here? T3 is given 40 Newton, M1, M2, M3 is given. So total mass will be how much? M1 plus M2 plus M3 equal to 20 kg. So directly we go for acceleration, A equal to F by M1 plus M2 plus M3. Calculate acceleration. So when we calculate acceleration, so we already know that T3 equal to what? F. So A equal to F by M1 plus M2 plus M3. In place of F, we can write T3 value, that is 40 Newton it is given, divided by M1 plus M2 plus M3, 10 plus 6 plus 4. So calculating this, we will get the answer 2 meter per second square. This is acceleration. So but I want tension T2 value. So what is the value of T2? So we know that T2 means it is T2 minus T1. We know that T2 minus T1 equal to M2 into A. This is what net tension. T2 minus T1 is equal to M2A. Or you can write T1 equal to M1A. We know the value of T1 means what? M1A. M1 is given. A we already calculated. So M1 is 10. 10 into 2 is 20 Newton. This is value of T1. Substitute in this equation. T2 minus 20 equal to M2 is 6. Acceleration is 2. Substitute here. So we will get the answer 32 Newton. In this problem, first we go for acceleration. Then you can choose this equation T2 minus T1 equal to M2A. In that first calculate T1 equal to M1A. Easily you will get the answer. Substitute. So the final answer is 32 Newton. So in this problem you have to remember this hint here. In the above example, three bodies are pulled with a force F. Acceleration T1 equal to M1A. In place of M1, keep as it is M1. In place of A, substitute the value. So when you remember this equation, you will get the answer 32 Newton. Now we go for the next concept, masses connected by springs or strings. Masses connected by spring or string. The first point, when two bodies of masses M1 and M2 connected by a spring are pressed and released, M1 A1 is equal to M2 A2, where A1 and A2 are their initial accelerations after release. This is the first case. Second case, if force F is applied on a body of mass M1 which is connected to another body of mass M2 and the two bodies move with acceleration A1 and A2 respectively, then observe this diagram carefully. M1, M2, these are the two bodies having masses M1, M2. These two bodies are connected by the spring. When this spring is pressed and released, so that the force will be equal to M1, A1 equal to M2, A2. Is it clear? This is what initial and their final acceleration. When we compress and when we expand, so action reaction will be equal. So we can write M1 A1 equal to M2 A2. or the total force you can write M1A1 plus M2A2. If a force is applied on the body of mass M1, if suppose you applied force on the mass M1 which is connected to mass M2 and the two bodies moving with acceleration A1, A2 respectively. Remember, when these two bodies pressed and released, M1A1 equal to M2A2. When you applied force on M1, M1 is connected to M2 with the help of a spring. So we want a total force M1A1 plus M2A2 because these two bodies together they are moving when we applied force. Then third point, a force F is applied on the massless pulley as shown in the figure. String connected to the block on the smooth horizontal surface. Then now they are going to apply force on the massless pulley. Here this is pulley. On this they are going to apply force. The string is connected to the block. This is block of mass M. This block is kept on the horizontal surface. Remember, this block is connected to this frictionless pulley, massless pulley. Means this pulley is having negligible mass. It is connected to the string on this horizontal surface. Then how to write force and tension? So force F is equal to 2 times of tension. Tension equal to mass into acceleration of the block. See here, this object is not suspended here. It is simply kept on the horizontal surface and this block is connected to the frictionless pulley with the help of the string. We are applying force in forward direction. So we know that force, whatever the force is exerted, it is equal to tension in the string. How much tension is created here? So you can observe T plus T. One is connected to the block, right? You can observe frictionless pulley. This string is connected to the pulley like this. Like this it is always connected. It starts to rotate like this along the pulley. So T plus T will be how much? 2T. 2 times of tension is equal to force in these cases. And tension is F equal to M. Keep as it is. Acceleration of the block we have to consider instead of acceleration due to gravity. Now we go for apparent weight in a lift or elevator. This is very important concept. We will get MCQs on this concept also. We go for this one. Apparent weight in a lift or elevator. A man of mass M is inside the elevator. A man is inside an elevator. The first point. If that elevator accelerates in upward direction, how to write the equation? A man is inside elevator. Elevator is moving in upward direction. Then this is relative to earth. So we can write the equation N minus mg is equal to ma. You can observe this diagram. The elevator is moving upward, right? So downward force is weight of the block is acting downward. W equal to mg. Normal reaction is acting upward, right? So W and normal reaction both are equal and opposite. So we can write N minus mg and elevator is moving upward. So F equal to ma. So this N minus mg equal to ma. Mass M is mass of the man. So first we have to write how to write apparent weight. When elevator is moving upward, we should write N equal to, or simply you can write F equal to M into G plus A. So why we have to write G plus A when elevator is moving upward? So you can feel yourself when elevator is moving upward or when you are sitting in a joint wheel. When it is moving upward, you feel very heavier because acceleration of a man of that joint wheel or the elevator plus we have to consider acceleration due to gravity G plus A. So your weight, apparent weight supposed to be increased. So we can write F equal to M into G plus A, or you can write N equal to M into G plus A, or you can use this equation. You will get the final equation M into G plus A. This just to remember this equation, right? So this is applicable only when elevator is moving upward. Then how to write a tension? Tension in the cable is T equal to mass of the elevator plus mass of the man into G plus A, because it is moving upward. Upward means G plus A, we already studied. M into G plus A. In place of M, we should consider elevator as well as man. This is a tension and this is apparent weight. Then second point, when elevator accelerates downward, exactly opposite. It is relative to earth, weight of the block, normal reaction, mg minus n equal to applied force ma. Or apparent weight will be m into g minus a, because it is moving downward. So when you are sitting in a joint wheel or when you are moving in the elevator in downward direction, we feel very lighter because the equation is g minus a. And how to write a tension in the cable? Same equation, m elevator, mass of the man into g minus a, because elevator is moving downward. G plus a upward, g minus a downward, remaining keep as it is. Same effect is felt when the elevator goes up with retardation. Same effect you can feel only when the elevator goes up with retardation. Retardation means when it is moving upward with decrease in acceleration. So we go for A equal to minus G, because it is retardation, deceleration. If an elevator falls freely, when it falls freely, when the cable breaks, then A equal to G, hence F equal to 0 or N equal to 0. That is, apparent weight of a body in freely falling is 0. Apparent weight increases in upward, apparent weight decreases in downward. Apparent weight is 0. There is no change in the weight. There is no apparent weight when it is a freely falling body, because it is completely under acceleration due to gravity. Third point, when elevator moves up or down with uniform velocity. If velocity is uniform, then how to write the equation? We know the equation n minus g equal to, this is what? ma. A is 0, acceleration is 0 because it is having uniform velocity. N equal to mg. This equation you can use when it is moving with uniform velocity. When it is at rest, when it is moving with uniform velocity, you can simply write n equal to mg. And tension is mass of elevator, mass of man into g. So there are three cases: upward, downward, rest. Rest means uniform velocity. Upward G plus A, downward G minus A, and when it is at rest or when it is having uniform velocity, this is simply G, because A is 0. Yes, go for multiple choice question on that concept. A lift is going up with uniform velocity. When the brakes are applied, it slows down. A person in that lift experiences. What is the answer? A lift is going up with uniform velocity, means apparent weight is 0 initially. When they applied brakes, suddenly the speed slows down or speed decreases. Then a person in that lift experiences, when speed decreases, whether he experiences more weight or less weight, normal weight or zero weight. Remember, he is going up. When the elevator is moving upward, you feel heavier, G plus A. Is it clear? But it is moving, its speed is gone decreasing. Then what is the answer? The answer you feel is less weight because of decrease in velocity, because of retardation. Exactly opposite to that, less velocity. Second question, a man drops an apple in the lift. He finds that the apple remains stationary and does not fall. The lift is. A man drops an apple. He is going to drop an apple. He is in the lift. He finds that the apple remains stationary and does not fall. The lift is. Options: going down with constant speed, going up with constant speed, going down with constant acceleration, going up with constant acceleration. The right answer is, it is going down with constant acceleration, because when he drops an apple, the apple comes down immediately, it will come to rest. The apple is at rest. The lift is. What about the lift? Yes, the lift is going down because it is at stationary. It is going down with constant acceleration. Then the next concept, man inside an artificial satellite. If a man is inside an artificial satellite, how to write the equation? First point, an artificial satellite orbiting the Earth in a circular orbit is freely falling body because its centripetal acceleration is equal to acceleration due to gravity in that orbit. Remember the first point. An artificial satellite means this satellite is revolving around the Earth in a circular path, means it is having centripetal acceleration. And it is revolving around the Earth with centripetal acceleration. That acceleration is produced by acceleration due to gravity. Is it clear? Then second point. In the above case, apparent weight of the man inside the satellite is 0. So apparent weight of the man, when that man is inside the satellite, it is 0. You can observe this equation. We know that mg minus n is equal to, we have to write ma here. Instead of that, I am going to write orbital velocity because it is a satellite revolving around the Earth. It is having orbital velocity. So we can write this equation. Mg minus n equal to m v naught square divided by r. So we can use this equation where v naught is orbital velocity because the satellite is revolving around the Earth with orbital velocity v naught. You have studied in gravitation chapter, you can remember. But what is the value of v naught? V naught means it is square root of g into r. Substitute here. Mg will get cancelled, r will get cancelled. So the final value is n equal to 0. That's why when a man is inside the satellite, apparent weight of the man is equal to 0. We go for multiple choice question based on that concept. The apparent weight of a man is 0 in an artificial satellite orbiting the Earth. In a circular orbit is a freely falling body. Yes, they had given the right statement, but we have to answer the reason behind that statement. We know that apparent weight of a man is 0 in the artificial satellite when it is orbiting the Earth in a circular orbit. What is the reason for that? They had given the option, its centripetal acceleration is equal to g. Its centripetal acceleration is not equal to g. Centripetal acceleration is greater than g. Centripetal acceleration is less than g. We know that centripetal acceleration is equal to acceleration due to gravity. So that apparent weight is equal to 0. Right? So option A is the right answer. You can remember this point. Artificial satellite orbiting the Earth in a circular orbit is freely falling body because its centripetal acceleration is equal to acceleration due to gravity. So option A is the right answer. Now we go for a tension in a string supporting bob. If a bob of mass m is suspended by the string, the bob is connected. If you have done simple pendulum experiment, you can remember. When the bob is stationary, tension T in the string is given by the equation T equal to mg. Right. Then third point. When bob is pulled up with acceleration A, tension in the string is given by, when it is moving up, m into g plus A. The next point, when the bob is allowed to move down with an acceleration A, then tension is T equal to m into g minus A. Is it clear? When it is at rest, mg. When it moves up, g plus A. When it moves down, g minus A. Here we considered string has negligible mass. The next point, when bob is pulled up and moving down with uniform velocity, it is moving up and down with uniform velocity, then again the equation is same, T equal to m into g. When it is moving up, g plus A. When it is moving down, g minus A. So A will get cancelled. So again the same answer we will get. Next point, when bob is falling freely, the tension T in the string becomes 0. When bob is freely falling, when it is not in contact with the string, if it is freely falling, then tension becomes 0. The next point, when the suspended bob is moving horizontally with acceleration A, the tension T in the string is given by the equation T equal to m into square root of g square plus A square. Remember this equation we can use only when the bob is oscillating or it is moving horizontally. Then next point, a bird is in a wire cage hanging from a spring balance. When the bird starts flying in the cage, the reading of the balance decreases. Suppose if a bird is in a cage made of wire hanging from the spring balance, that cage is hanging with the spring balance. When the bird starts flying inside the cage, bird is flying inside the cage is suspended, then the reading of the balance decreases. Next point, in the above case, if the bird is in a closed cage or airtight cage and it hovers in the cage, the reading of the balance does not change. So here the reading does not change, but in the above case, the reading of the balance decreases. The next point, in the above case for a closed cage, if the bird accelerate upward, reading of the balance is, reading will be weight of the bird plus ma, it is moving upward. Is it clear? W plus ma we have to write. You can observe all these cases. In the first case, reading of the balance decreases because it is suspended with the help of a cage. It is hanging. So when a bird starts flying, that indicates the weight starts to move down. Weight starts to move down means G minus A, balancing rate decreases. In the second case, it is completely closed, airtight cage here. So in these cases, there is no change, there is no movement up and down. So it does not change, reading does not change. But when the same bird starts to move up, so we should consider G plus A, means weight of the bird plus m into A, mass of the bird and its acceleration. So these are the keynotes to remember. When you got the multiple choice questions, you should remember all these points carefully. Yes, go for the similar question. A bird is sitting in an airtight cage suspended from the spring balance. If the bird starts flying, then the reading of the balance will. What is the answer? So it will remain unchanged because it is an airtight cage, right? Yes, till now we studied the very important concepts from the chapter Laws of Motion, and all these points you have not studied in your theoretical classes, in your regular classes. In your CET, multiple choice questions will be based on these concepts. You should remember all these concepts, and I had given the brief synopsis regarding the new concepts of this chapter, and also we studied some multiple choice questions related to that concept. So this is part 1. Again we go for the second part. Again we can solve multiple choice questions.